In this video, I'll be going over the secant and cosecant graphs. So what we have in this image are the cosecant graph up top and then the secant graph down below. Let's first talk about cosecant. So we know that cosecant is the reciprocal of sine of x. Okay, so we can think about it that way, or we can say sine of x is equal to 1 over cosecant. So cosecant and sine are related to each other. What we see in this image is that we have the curve for the sine graph. It's in here, right? And notice how that sine graph is relating to these portions of the graph. So the part I'm tracing right now is the cosecant graph. So what we do to graph a cosecant function is we first graph the sine function, and then based on wherever the maximum values and the minimum values are for the sine graph, that's where the minimum and the maximum values are for the cosecant graph. And then the only other piece that we really need to pay attention to that is new is what these dotted lines are, and these are asymptotes. Okay, so the asymptotes are going to appear. So these are asymptotes, and these appear when sine of x is equal to 0 and when cosecant of x is undefined. So let's make a quick table of values for cosecant. So cosecant at 0, well, let me make a separate column here. All right, so we have an angle theta, and then we have sine of that angle and cosecant of that angle. So let's first fill out the column for sine. So sine at 0 is 0. Sine at pi over 2 is root 2 over 2. Sine at pi over 2 is 1. And then we go back down to root 2 over 2 and then 0. Now cosecant is the reciprocal of what we have for sine. So cosecant of 0, well, that's the reciprocal of 0. So that's 1 over 0, which is undefined. Cosecant at pi over 4 is going to be 1 over root 2 over 2, so just the reciprocal. Sine at pi over 2 is going to be 1 over 1, which is 1, and that is this position right here. Sine and cosecant are both equal to 1, so the graphs come together at that position. At 3 pi over 4, I get 1 over root 2 over 2, so that is like this position right here. And then cosecant at 0 is the reciprocal of 1 over 0, or reciprocal of 0, which is 1 over 0, and that again is undefined. So that's at pi is where we had that undefined value. We also had an undefined value at 0. So that's where the graph is undefined, and that's where the vertical asymptotes are. Okay, let's move down to the second graph, secant and cosine. Again, inside we have the cosine graph, and then at the maximum values and the minimum values, that's where the secant graph appears. And if I make another table with cosine, secant, and theta in this table. So cosine of theta, if we start at 0, we're going to get a value of 1, and then that value for cosine is decreasing. We get root 2 over 2 at pi over 4. We get 0 at pi over 2. We get negative root 2 over 2 at 3 pi over 4, and then at pi, and this should be negative 1. Okay, and then it's going to increase again. So let's think about the values for secant. Secant at 0 is just the reciprocal of cosine, so that's 1. Secant at pi over 4 is the reciprocal of this, so 1 over root 2 over 2. At pi over 2, secant is 1 over 0, which is undefined. So at this point right here, at pi over 2, that's where the graph that's where secant is undefined, so that's where the asymptotes are, or that's where one of the asymptotes is. And then we're going to drop down here, and then negative 1 over 1, which is negative 1. So we're down at this position right here. So what we need to be able to do in order to graph a secant or cosecant graph is, or secant or cosecant function, is to first graph their reciprocals, so cosine and sine, and then from there we need to identify the asymptotes, and then we can graph the secant and cosecant functions. So let's give an example for each of these. So here's our equation: y equals 3 secant of x plus pi over 2. We want to find the period, amplitude, horizontal and vertical shifts, equation of the asymptotes, domain, and range. So we'll begin by considering the equation for y equals 3 cosine, and then I'm going to write this in standard form. Okay, just so we can be explicit about what any horizontal or vertical shifts are. So we're going to proceed by getting all the information for the cosine graph. So the amplitude here is the absolute value of the leading coefficient, so that's 3. The period length is 2 pi over the b value, which is 1, so 2 pi is the period length. For a horizontal shift, we are moving left pi over 2 units, and there's no vertical shift. And then we'll come up with the equation of the asymptotes, the domain and range, after we graph this. So what I'm going to do is I'm first going to graph, I need to figure out what the horizontal axis looks like. So first, we have a period length of 2 pi. So again, we cut this in half, and then we cut the first half in half again, so that's pi over 2, and then 3 pi over 2. So here is the initial period length cut into quarters, but then we want to shift left pi over 2. So each of these values, I'm going to subtract pi over 2. So the shifted number line, 0 minus pi over 2, I'm going to have negative pi over 2. Pi over 2 minus pi over 2 gives me 0. Pi minus pi over 2 is pi over 2. 3 pi over 2 minus pi over 2 is 2 pi over 2, or just pi, and then we get 3 pi over 2. So this is what our period looks like when we cut it off into quarters. So I'm going to label everything. Negative pi over 2. Okay, we have an amplitude of 3. The cosine crosses the horizontal axis at the quarter points, and then it's going to start maximum here. It's going to come down here. So the cosine graph looks like this. Okay, so there's the cosine graph. Once we have the cosine graph in place, we can go ahead and start thinking about what the secant graph looks like. So what we want to do is we want to graph the asymptotes. And remember, the asymptotes are wherever the graph of cosine crosses the horizontal axis. In other words, when is cosine equal to 0? It's at those positions. It's at 0 and pi. So in order to come up with the secant graph, what we do is we just start at the maximum values and the minimum values of the cosine graph. So the minimum value is going to be here, so the graph looks like this. I'm going to give a couple more asymptotes. So we have an asymptote at pi, because that's when the graph is going to hit 0 again. Okay, so we're going to have, I guess I did that too big here. Okay, so we're going to have an asymptote here, or at pi. So this curve is going up towards both asymptotes. So this is 2 pi. And then I could also have part of the graph here and here. So the black portion of the graph corresponds to the secant graph, y equals 3 secant x plus pi over 2. Okay. Now, it's okay to leave the cosine portion of the graph on here. It just might be a good idea to label it. So this is y equals 3 cosine x plus pi over 2. We could also erase the cosine portion, so we just have the secant graph. So it would look something like that. All right, now let's find the remaining pieces. We want the asymptotes and the domain and range. So to find the asymptote equations, what we want to do is we want to come up with a general equation that represents all these asymptotes. And the asymptotes, there are an infinite number of asymptote lines for this graph. So we want to come up with a general equation that we can use to find all of these asymptote equations. So what we want to do is all of the asymptote lines are vertical, so they're going to be y is equal to. And how we figure this out is the formula is y is equal to, how I write this is any asymptote plus the distance between the asymptotes. Okay, so if I wanted to write this equation, an equation for the asymptote lines, let's just pick one of the asymptotes. How about pi, this asymptote that's right here? Okay, so if we wanted to write the equation, we'd say y is equal to any asymptote, well the asymptote I chose is pi, plus the distance in between the asymptotes. Well, this distance right here between pi and 2 pi is pi. Similarly, the distance here is also pi. So no matter where those asymptotes are, they're always pi units away from each other. So we're going to say plus k times pi for any k integer. And this just means if we pick some integer k, like 5, and I plug it in right here, we would get y is equal to pi plus 5 pi, so y is equal to 6 pi. What that means is at 6 pi there would be an asymptote. So this is the equation, the general equation we would want to use. All right, and then lastly we want to come up with the domain and the range. Well, the domain here is not all real numbers like a sine or cosine graph. The domain here is everything except for the values of the asymptotes. So what we'd say is the domain is, we can write this in set notation. We can say all x such that x does not equal, we can use the exact same formula for the asymptotes. So what this is saying is we figured out the equation, an equation for the asymptotes. So what this means is x takes on every single value except for whenever we have an asymptote. And then the range is, well, the smallest y value is -3, and the largest, the cutoffs are at -3 and 3. So we have all of these y values and all of these y values. So the range is going to be -infinity to -3. We're going to include -3 because the graph actually passes through there, union 3 to infinity. Now, the most challenging part of these types of questions is the asymptote, the equation for the asymptotes. So we'll see that again in the next example. So let's go through the same process for this equation. Y is equal to cosecant of 4x minus 4 pi over 3 minus 3. So we begin by writing this out as a sine graph, or a sine equation. And I'm going to factor out this 4 here to write this in standard form. Now this is a little tricky. When we factor out 4 from 4x, we're left with x minus, so what is going inside of here? Well, it comes out to be pi over 3. And you can check this just by multiplying or distributing out, and we get to what we started with. Okay, so for the amplitude, we're going to say it's 1. absolute value of the leading coefficient, so that's 1. The period is 2 pi over b, which is 4, so pi over 2. Horizontal shift, we're moving right pi over 3 units. And in the vertical shift, we're going to say down 3. So this one's going to be kind of messy, coming up with the horizontal axis and accounting for what the shifts are. So the period length is pi over 2, so cutting that in half, we get pi over 4. Cutting that in half again, we get pi over 8. Then adding pi over 8 and pi over 4, we get 3 pi over 8. And now what we need to do is we need to add pi over 3 to each of these values. So it's a good idea to get a common denominator so that you can add these. So when I add pi over 3 to each of those values, this is where we end up. Now take a moment and really make sure that you're able to add pi over 3 to each of these values and get the values that we have down here. One thing that's useful is converting pi over 3 into a denominator of 12 and 24 so we can add some of these fractions together. Okay, so let's go ahead and graph the sine function. We have pi over 3, 11 pi over 24, 7 pi over 12, 17 pi over 24, and 5 pi over 6. Our amplitude is 1, so we're going up to positive 1 and negative 1. However, we're shifting down 3 units. So from 1 going down 3, we're going to end up at negative 2. Negative 1 down 3, we're going to end up at negative 4. So this new midline is here at negative 3. Okay, so we don't have any vertical reflection, so sine is going to cross at the beginning, the middle, the middle, and the end of the period, and the max value is going to be here, and the min value is going to be here. So this graph looks like this. And then remember, the asymptotes are wherever the sine graph crosses the horizontal axis. So it's at the beginning, the middle, and the end of the period. So for the cosecant graph, that's going to hit wherever sine is at a maximum and where it's at a minimum. So the red graph here is the sine graph. Okay, so for the asymptotes, again, we say pick any asymptote, how about pi over 3, plus k times the distance in between asymptotes. Well, this is a little bit tricky. The distance in between the asymptotes is going to be 7 pi over 12 minus pi over 3, which comes out to 7 pi over 12, that's going to be 4 pi over 12, which is 3 pi over 12, which is pi over 4. So that is an equation of the asymptotes. We could have just as easily have said y is equal to 7 pi over 12 plus k times pi over 4, right? It doesn't matter whether we start with this asymptote or this asymptote. We could have said y is equal to 5 pi over 6 plus k times pi over 4. Any asymptote will work here. All right, so there is an equation of the asymptotes. And then lastly, let's discuss what the domain and range are. So the domain here is going to be all x such that x does not equal one of these equations for the asymptotes. So all x except for pi over 3 plus k times pi over 4. And then for the range, we're going from negative infinity up to this position, negative 4. union, and then we pick up again at 2, and we go to positive infinity. So we're going to say 2 to infinity, and those are bracketed.